Hello everyone. In this video, I'm going to be demonstrating the creation of a Glowscript program from scratch. And the particular problem I've chosen to do is dropping a box onto a spring. And so the goal is to have it bounce up and down repeatedly. So let's start by drawing a few things. So I'm going to need a floor to put everything on. I'm going to need a spring and a box. So let's start with the floor. So I'm going to define the floor as a box object. Now the box object requires a few things. One is a position. This defines the center. So I'm just going to place that at the origin. Second thing it requires is basically the dimensions, the length, the width, and the height. Okay, so for that I can do size, and that's a vector. So each of these is going to tell it how far horizontally, up, down, in, and out. So horizontally, I'm just going to make up some numbers here. Let's say 10. Vertically, I want it to be very thin, so I'll say 0.1. And then the in and out direction, I'll say 10 as well. All right, so let's run that just to see what it gives us. All right, so it gives us a flat surface like that, right? So I can rotate it, you can see it's flat. Okay, so next we want to make a spring. Now a spring is a special object called a helix. So to show you how we go about doing that, let's go to the help menu here. And if we go to glowscript.org, that will tell us how to make a helix object. If we go to glowscript.org, we can go to help menu here. And down here there's something called helix. And so this is how to make a helix. So it requires a few things. One is the position. This basically is the anchor point that's going to draw it from. Axis is tells it its orientation. So if you make 5, 0, 0, that means it's going to stretch 5 units in the x direction, 0 units in the other directions. And then the radius is basically the thickness of that coil there. Okay, so let's go back to our program here. So we're going to make the spring. So it's a helix, and I need to provide it with a position. So I'm going to place that one at the origin as well. And then I need the axis, so this tells it its orientation as well as its length. So I wanted this to point straight up, so let's start with 0, 1, 0, just to see what that looks like, and then we'll make it a radius of, I don't know, 1. Alright, so that it draws something like that. So just to show you what happens when I change some of these things, if I change the axis value to 2 there, then it makes it a little farther up, right? So eventually we're going to be changing this attribute of the spring, because if the box is going to be falling onto the spring, then we want the spring to be able to compress. So the thing that we're going to be changing is the axis value. Okay, so let's bring this down to 1 again. Actually, let's do this. Let's create a variable. This is going to be the length of the spring. Actually, let's make it the relaxed length, right? So this is sort of the natural length of the spring, right? So then I can just change that to L, right? And then it should look just like that. Okay. So we have the floor, we have the spring. Now let's draw the box, or let's say a block. Right. So this is a box object, just like the floor is. So this also needs a position attribute. So I'm going to place it directly over the spring, so it's 0 and the x. I want to be able to control the height just by changing one single number. So I'm going to call this h and 0, and then make a new variable up here called h. So let's just make it 2 for now. We can always change it later. So this is the initial height of the block. Alright, so the block also needs a size. So let's define the size. Let's say it's 1 in each direction. So it's basically just a cube. So let's see what this looks like now. Okay, so it's above there. So let's change something about the spring. The spring is a little bit too big, as you can kind of see. Oops, let me zoom in there a little bit. As you can kind of see, it looks like the block will just fall straight through the spring. So let's reduce the radius of the spring to, let's say, 1/2. All right, so that looks better. Okay, so now we've drawn our objects. Now let's work on animating the motion. All right, so anytime we animate the motion, we're always going to need some kind of while loop. Now the condition for the while loop can be basically anything you want. So let's make it a time-based condition. So while t is less than or equal to 10. So this basically says we're going to have this thing run for 10 seconds. Okay. So because I'm referring to a variable called t, I need to make a set a value for that up here. So I'm going to basically start my timer at t equals 0. So this is the initial time. And then we're also going to need a time step. So let's set that as, let's say 0.01. Okay, and let's comment there. So this is the time step. All right. So the while loop, this means it's going to run for 10 seconds. All right. So we always tab after a while loop here, and the first thing here is always some sort of pause so that our program doesn't run too fast. If we don't have this in here, then it'll happen almost instantaneously. We can't see anything. So this is makes sure the animation doesn't run too fast. Alright, so in order to animate the motion, we have to figure out the acceleration. And then from the acceleration, we update the velocity, and from the velocity, we update the position. But the acceleration is going to depend on the force. So while it's in the air, the force is only that due to gravity. Okay. So what I'm going to do is I'm going to create a new variable up here called g. So that's a 9.8. This is the gravitational field strength. Oops, gravitational. And so then the gravitational force, which I'm going to call Fg, is going to be a vector with 0 in the x, and then in the y direction, it's going to be the mass of the block times g. Okay. Now currently I don't have anything defined as the mass of the block. So what I'm going to do is I'm going to up here, I'm going to make a new attribute for the block. Just call it m. Right. So let's say m equals 1. This is the mass of the block. So then I'm going to make this minus block dot m times g. All right, so this says, look at the block object, find the m part of it, and that is going to be the mass here. And then we're multiplying that by g, and then I need 0 for the z direction, right? So this is the gravitational force. And then based on the gravitational force, I can calculate the acceleration. So block dot a, so this is the acceleration of the block in particular. Now, the block doesn't have an a attribute already, but by doing this, I'm going to be setting a value for it. So block dot a equals, it's going to be the gravitational force divided by the mass of the block. Okay, so that sets the acceleration. And then I can update the velocity, so block.v equals block.v plus block.a times dt. Add some comments here, so calculate acceleration, update velocity. Next line, block.pos equals block.pos plus block.v times dt. So this updates the position. And then finally, I'll increment the time. So t equals t plus dt. All right, so this updates the time, right? If I didn't have this in here, then this loop would continue running forever, right? Because what this is looking for is that t is going to be less than or equal to 10. All right. So I'm going to run this. Now, this isn't doing anything with the spring now, so it should just fall. So let's just focus on that part, right? So one of the things I recommend when you're doing these is work on little bits at a time and make sure those bits are working. Now, this is not going to work, and let me see if you can figure out why. All right, so we're going to get an error. All right, so it cannot read property plus of undefined. Oftentimes, when you see an error like that, it's because you've defined a property of an object that doesn't yet exist, okay? And the problem is actually in line 30 here, okay? So what this is saying is take the v property of the block and add to it block.a times dt. Now, block.a times dt, those have numbers associated with them, right? So that's not a problem, but block.v doesn't yet exist, so you can't add a number to something that doesn't exist yet. Okay, so let's add a v. So v equals vec 0, 0, 0. So that means that's just going to set the initial velocity of the block equal to 0. So now when we run it, it should actually work. And it doesn't. So what is the problem there? Okay, so it's saying the problem is in line 27 with this. Now looking at this, I don't see any problem with this. So usually what that indicates to me, when I look at a line and say there's nothing wrong with that, I want to look a little bit above that. And so one thing I'm noticing here, when I put the comma on this line, I actually put it after the comment. And so anything after the hashtag there is ignored. So I think that was the problem. So now let's run it. Yeah, okay, so now it's falling, all right? So that part is good. So now we need to incorporate the effect of the spring itself. So what we need to do is we need to look for the moment that the block hits the spring. Now that is when the height of the block is less than the original length of the spring. When that happens, we need to kick in this additional force, right? So it's not just gravity, but gravity plus the spring force. Okay. So what I'm going to do is, after I calculate the gravitational force, let's add an if statement in here that looks if the height of the block is less than L. So if block.pos.y, that's the y coordinate of the block, if this is less than or equal to the height of the original height of the spring, right, colon, so it should indent the next line. So then what we want to do is we want to calculate the spring force. So I'm going to make a new variable, FSP, that represents the spring force. The spring force is the spring constant times how much the spring has stretched by. So I'm going to need a spring constant here. So I'm going to make a new variable here. I'm going to make up a number. We can always change it later. So this is the spring constant, right? So let's say it's 100. So it's the spring constant. Now it also depends on the stretch or the compression. Okay, so this is going to be a vector here. So we're going to need to multiply this by the current length of the spring minus the original length of the spring. So the current length of the spring, remember, it was that axis value, right? So spring.axis. So if you look at this current value here, spring.axis is going to spit out 0, 1, 0. So that is a vector that points up to the original. At first, it's going to be the original length. Okay, and I want to subtract from this the original length, which is vec 0, L 0. Okay, so when the block first encounters the spring, it's gonna see spring.axis. Well, that is 0, 1, 0 or 0, L 0, and so is the original length. So the spring force is going to be 0 at first, and that's fine. That's what it should be. And there's one other thing I need to add here. I do need to add a minus sign, right? I need to make sure that the force is going to be pointing upward. As the spring compresses, the length of the spring is going to shrink. So this is actually going to be a negative number. So the negative here makes it point in the upward direction. Right, so this calculates the spring force, and then I need to figure out the acceleration. So it's going to say block.a. Now this time the net force is gravity plus the spring force. Right? I have both of those in there. This is all divided by block.m. Okay. Now I need to make one other change here. So let me well, there's a couple of things I need to change, but let me run it just to see what happens here. It's going to fall straight through. Yeah. Part of the reason that's happening is because see how the acceleration I have here, if it happens to be true that the height of the block is less than the length of the spring, it's going to do this and it's going to calculate the acceleration, and then it's going to move on to this part here, and it's going to recalculate the acceleration again. So effectively, the if statement did nothing. So let's do this. Let's copy and paste this to before. This way, it calculates acceleration assuming only gravity. If it happens to be true that the block is, the height of the block is less than the original length of the spring, it's going to recalculate the acceleration. Now this is still not quite going to work because currently spring.axis and 0L0 are exactly the same thing, and they will remain the same thing. Okay, so one thing that we need to do is we need to change this so that spring.axis equals block.pos. Right. In other words, as the block moves down, we want to shrink the length of the spring correspondingly. All right, so let's see what happens when we do this now. All right, so it's better, right? It's doing things. It is bouncing, but a couple weird things are happening. First off, if you'll notice, the block is kind of passing through the spring a little bit. Right? Let's watch it again. See. And that's the reason that's happening is because the position of the block is defined relative to its center. And so we need to adjust this if condition a little bit. So what we need to do, let's add half the height of the block here. Okay, so the reason for doing that is so that this will trigger when the bottom of the block hits the spring, not when the middle of it hits the spring. Okay. And then for this part, we also have to do minus block.height divided by 2. Okay. Let's see if that part is better. All right, so okay, so we're getting in here. Cannot subtract a scalar and a vector. So the problem is here, spring.axis is a vector, block.pos is also a vector, and I tried to subtract a scalar from that. Okay, so I need to fix that. So I have a couple options here. Either I could turn this into a vector, or I can keep that, and since the only things that are changing about these are the y coordinates, I can just do dot y on each of these. Alright, so that's better. Okay, so you may notice that something weird is still happening there, and that it keeps bouncing higher and higher and higher over time, right? And that is a problem. So it could be a problem with the numbers that we have here. So let's just try playing around with some of these just to see what happens. So let's say we increase the spring constant. Okay, we're still getting that problem, right? So it's not that. We could also try decreasing the mass, right? So let's say this is 0.2. Still happening. Okay, so it's not anything having to do with the mass. It could be a time step issue. This is something that happens a lot um, whenever you're simulating something. Sometimes if your time step is too big, then the energy isn't actually conserved. So let's actually shrink this down. Let's cut it down to half of what it was before and see what happens. Yeah, so that's a whole lot better, right? It's still looking like it's getting a little bit higher and higher each time, which is not ideal. But let's shrink it a little bit. Now our animation is going to run slower because it has a lot more computation to go through. But it should get better and better. Let's see if it goes to the same height each time. Yeah, it's looking like it. Okay, that looks pretty good. Or good enough. The smaller you make the time step, the better it will actually work. But for now, let's just say that that looks pretty good. All right. So let me just add some final comments on here. So the if statement here is check if block has hit spring. Here is calculate spring force, calculate acceleration, adjust height of spring. Okay, so it all looks good now. So let's give it a name. Let's call it block balancing on spring. Save the results, and we're good to go.